In the Klondike River at the end of the 19th century, many villagers took their chances during the Great Gold Rush as a prospector. The prospectors work by filtering the river stream to find gold dust from eroded river rocks. The gold dust collected over time is not much. Some catches probably only weigh 2 times 10 to the power of -3 grams, or 0.002 grams, or simply 2 milligrams, the format I'm sure the prospectors would rather use because it's easy to say and write. Now, we can only imagine what format the scientists would use when they need to measure and operate on the mass of each individual gold atom. In a gram unit, one atom of gold will have a mass of 3.2 times 10 to the power of -22, which is an atomically small value. Not very efficient to say and write. So, the scientists came up with the concept of relative atomic mass to allow for easier calculation and record-keeping of atomic mass in science experiments, especially chemistry. What is relative atomic mass? The relative atomic mass, or AR, of an atom is the average mass of one atom of that element compared to 1/12 of the mass of one carbon-12 atom. It is a ratio rather than the actual mass, and therefore doesn't have a unit. Just like expressing the weight of your insecurely thick classmate by dividing it with 2 times the weight of your school cat. Why carbon-12, you ask? Because it has suitable properties, such as abundance, can be found almost anywhere, and does not decay as it is radioactively stable. Each element has its relative atomic mass written on the periodic table of elements. If we make a comparison, then all the elements on the left and above of the carbon have a lower relative atomic mass value, while the elements to the right and below have a higher value. Now, most of the elements naturally exist as mixtures of different isotopes. Thus, to obtain the relative atomic mass of an element, we need to calculate it based on the abundance of each of the element's isotopes. For example, in the Earth's crust, both uranium-235 and uranium-238 exist naturally. If we take a sample of the crust and measure the uranium isotope's quantities, 99% is uranium-238 and only 1% is uranium-235. Therefore, the relative atomic mass of uranium is calculated by multiplying the relative atomic mass by its abundance and adding the results. For copper, there are 2 stable isotopes, Cu-63 and Cu-65. Both of them are used as the ingredients for radiopharmaceuticals for diagnosing diseases. By knowing the abundance of each isotope, the relative atomic mass for copper can be determined. In our next video, we will learn about relative molecular mass and relative formula mass. Stay tuned and don't forget to subscribe to our channel so you won't miss a lesson.